Assalamualaikum and hi to all the viewers. My name is Muhammad Syed bin Syukur.
My name is Muhammad Bahaki Fitri bin Muhammad Nawi.
My name is Muhammad Rafiuddin bin Muhammad Khair.
My name is M.AlifAiman bin Saifuddin.
We are from Polytechnic Shah Alam. So for today we would like to talk about our project, which is the study of incorporation of Expended Clay Agggregate, Leca and fly ash in Mortar Propertise. Okay, so what is waste generation fly ash? Waste generation fly ash is a hazardous material produced from thermal power plant and has been approved as a potential alternative ingredient in making concrete as well as Leca.
Next, our problem statement is: first, waste generation from thermal power plant; second, fly ash cost, environmental problem, and the next, standard brick is quite heavy. Our product objectives are to determine the compressive strength of mortar properties and to study the density of mortar properties.
Next is the significance of study, where the addition of fly ash and also Leca would improve the properties of mortar as well as to reduce the environmental impact that caused by the waste generation of fly ash. Novelty research. The use of Leca and fly ash as partial replacement in producing lightweight concrete or LWC surprisingly gives a best result. Based on the result, it shows that the use of fly ash as cement replacement resulting in increase of compressive strength, while at the same time increasing the density of bricks. In the presence of Leca as cement replacement, the density of bricks can be decreased. From the data, it shows that the use of Leca resulting in the decrease of compressive strength and density of the brick. Next is the method. For the mixed proportion, we use three different mixed proportions based on the trial 1, trial 2, trial 3, and lastly mixed proportion for the product. Compressive strength at 7, 14, and 28 days for trial 1. For trial 2, 3, and brick product, the compressive strength at 7 and 38 days. Alright, this is the material we use. The first one is sand or fine aggregate. The second is fly ash. Third, cement. And last is the lightweight expended clay aggregate or Leca.
Next, hardened properties trial 1, fly ash. This is mixed proportion of fly ash as partial replacement of cement. As we can see, the table, the quantity of sand and water is same. Then quantity of fly ash increase each percentage and quantity for cement decrease each percentage. So this is bar graph and line graph compressive strength mortar for fly ash. The graph show the result of compressive strength test conducted for cube by using fly ash as a cement replacement for 7, 14 and 28 day of curing period. The graph show the result of compressive strength test conducted for cube by using fly ash as a cement replacement for 7, 14 and 28 day of curing period. In compressive strength test, 5% fly ash as a cement replacement got the highest strength result for 28 days curing period, which is the value of strength is 22 meganewton per meter square compared to others. Percentage of fly ash and 25% of fly ash as a cement replacement got the lower result of compressive strength, which is the value of strength is 18.33 meganewton per meter square for 28 days curing period. The compressive strength by using 5% for 28 days got the highest strength of fly ash as a cement replacement, show increase for 28 days curing period compared to 7 day and 14 days curing period. For outcome for this result, replacement 5% fly ash give a better strength compared to control for 7, 14 and 28 day curing period.
Next, hardened properties, trial 2, Leca. So this is a mid proportion of Leca as partial replacement of sand. So as we can see on the table, the quantity of cement is same and the quantity of fly ash is 0. While the quantity of sand is decreased for each percentage and the quantity of Leca is increased for each percentage. So this is line graph and bar graph for compressive strength of mortar Leca. So as we can see, the compressive strength by using 10% of Leca as a sand replacement show decrease for 28 days of curing period compared to 7 days of curing period. This is maybe due to the reason that as increasing water absorption by Leca causes the strength of Leca decrease. So for 28 days of curing period, the graph show the use of 0% of Leca get the highest strength, which is the value of strength is 16.65 meganewton per meter square as a control, and 30% of Leca got the lowest strength, which is the value of strength is 4.8 meganewton per meter square. So the outcome for this result, replacement with 10% Leca give better strength compared to control for 7-day curing period. So the graph show the result of the compressive strength test conduct for cube by using Leca as a sand replacement for 7 and 28 days of curing period. So 10% of Leca as a sand replacement got the highest compressive strength result for 7-day curing period, and the value is 18.05 meganewton per meter square compared to the other percentage of Leca. And 30% of Leca as a cement replacement got the lower result of compressive strength, which is the value of the strength is 4.1 meganewton per meter square for 7 days of cure period.
Okay, back to me again. So for now, I would like to talk about our trial 3, which is the cube concrete with mixture of fly ash and Leca as a partial replacement of sand and cement. Okay, so what is the difference between the others trial that we have conducted? Okay, so for this trial, we only use 5% of fly ash, and for Leca, we only use 3%, 5%, 7%, and 10%. Okay, as you can see on your screen at the table, we only conduct 5 different types of concrete cube. So for all the concrete cube, the percentage of fly ash is the same, which is 5%, but for Leca, we only use 3%, 5%, 7%, and 10%. And for the 0% represent as the control brick. Okay, so this is a graph of compressive strength for 7 days and 38 days of curing for trial 3. And as you can see that the use of 5% of fly ash and 10% of Leca gave a better compressive strength compared to control and the others type of cube concrete. Okay, the next one I want to talk about our product. So for our product, we only use 5% of fly ash and 10% of Leca. So why we use 5% of fly ash and 10% of Leca? Because from trial 1, we got the highest compressive strength is 5% of fly ash, and for trial 2, the highest compressive strength is 10% of Leca. So we combine these two results and make our product. and this is also have been proved by conducting a trial tree. And for the trial tree, we got the highest composite strength is 5% of fly ash and 10% of Leca. And as you can see on your screen, this is our mixed proportion for product. Okay, so this is the table of composite strength for our product brick, and as you can see on the table, for the product and the control brick, we achieve the minimum standard composite strength, which is 7 Newton per millimeter square, and this is based on the British Standard Institute states. Okay, so this is the graph of composite strength for 7 days and 28 days for trial 3. And as you can see, the highest composite strength is 10.15 Newton per millimeter square for product for 28 days. Okay, so this is the surface texture for our product brick, and at the left hand side it shows the surface texture for control brick, and the next picture shows the surface texture for our product brick. And the surface texture for the product brick is kind of rough due to the presence of Leca. Okay, for the conclusion is the use of fly ash give effect to the brick density and composite strength. This show at the trial 1, the more percentage of fly ash used, resulting in increase of composite strength, while at the same time increase the density of the brick. So to reduce the density of the brick, we use fly ash. This show at the trial 2, the more percentage of Leca used, resulting in the decrease of composite strength, while at the same time reduce the density of the brick. So from these two trials, we combine and product our final product. So for this product, we only use 5% of fly ash and 10% of Leca. And for our product, the composite strength, we achieve the minimum standard of composite strength, which is 7 Newton per millimeter square. And this is based on the MS 761972. So that's all from us, and thank you for watching.